that I have to do that every day. I wish it would just save my settings. Okay, should be good. Every day, Antonio, every day. All right, looks like we got the height is 24. The angle of elevation is 32. I like it, and that would be the ramp length, so I like it. The good old sine. So your picture looks exactly like my picture, so I'll just go ahead and show my picture. So there should be an equal sign before that fraction. So it should be sine of 32 equals 24 over x. But you knew that, right, Katie? Because without that equal sign, you're telling me sine of 32 times that fraction, which doesn't make sense. Nice. That's a valuable trick, that whole swapping the diagonals on an equation like that. Super useful. So people that are watching this video, the recorded session, many of you, well, I wouldn't say many of you, like 10 of you in class haven't done your Unit 1 test yet. And the locking date is this Sunday, February 7th, which happens to be Super Bowl Sunday. So while everyone's enjoying the food and the game, if that's what you do, the rest of you will be doing your math test. But really, people that are in this class should be on pace. You know, if a week shouldn't pass by and you haven't done the test yet, it shouldn't happen. And in my opinion, you probably shouldn't be in this class if you let that happen. Because when you have computer problems an hour before the locking date and you can't log in or you can't get on for whatever reason, you know, that's part of the agreement of going to online school. You take that responsibility. And waiting 2 weeks before doing the test, it's not good. So we got 45.5. Some people say 45.3. So what is the answer? So looks like two people, 45.3. Yeah, 45.28 becomes 45.3. I agree with you, Dianica. Yeah. Yep. Katie, type it in again if you haven't yet, and see if you get the same answer they do. I'm getting a lot of 45.3s as the answer in chat. Okay, yeah. Okay, so you must have just typed in something wrong, or maybe just misread it by accident. No worries, I do it all the time. So 45.3. Yep. Okay. Yeah. Does this problem look familiar to anybody? Why does it look familiar? I'm just curious. It was in the practice module. It was, yes. Yes, I Maybe I was just lazy this morning because usually I create my bell work the morning of, and this morning I decided just to go to the practice module and pull the first problem that I saw instead of creating my own. I know, how original of me, right? Yeah. All right. So today is day 1 of 2.05, the unit circle and reference angles. All right, so we're going to calculate the ratios based on a given angle around the unit circle. So it looks like this is relatively a long lesson. I have a total of 20 slides. We are now on slide number 3. Will be recorded as always. Right now, slide number 4. Make sure you have your paper and pencil. All right, well, that's a blank slide. Okay, here we go. Slide number 6. So maybe it's not that long as I thought. All right, make sure I'm recording. Okay, the trig ratios. This is an important slide, so make sure you write this down. Trig ratios. Again, this is important. Diagram, maybe not so important, but I would still maybe write it down. The sine of the angle is equal to y, your y coordinate, the y value divided by the radius. So make the association that sine is the y value. That's important. So this slide, this concept right here, we'll be using the next 3 units. So this is important that you make this relationship now, this connection. So sine is y over r. Cosine is the x value. Cosine is x divided by your radius. So the x coordinate divided by your radius. And then tangent, just kind of like slope, y over x, right? So tangent is y divided by x. These are the coordinates. This is important. Cosecant, secant, cotangent, maybe not as important because we'll be dealing primarily with these 3 fundamental trig functions. But everyone should know that sine and cosecant are just inverses of each other. Cosine and secant are reciprocals, and then tangent and cotangent reciprocals. All right, y'all need more time writing this down, or everyone good? All right. You know, there's studies that show that writing stuff down versus like just looking at or taking a picture of it reinforces the learning. Just saying. So if you're going to take a picture, maybe do both. Take a picture and write it down. I can't read your own writing. Oh, that's not good. So instead of writing letters and numbers, I need you to draw numbers and letters so it looks nice. And you're going to tell me that you're not an artist. Well, Okay, I got you. Well, good thing they're recorded. All right, angles. So angles past 90. All right, so we must use the reference angle, it's called. The reference angle is the alpha angle. So this is the Greek symbol for alpha. It's Greek letter A. So if we are past 90, which in this case it is, we're in quadrant 2, the angle of reference, the reference angle it's called, is alpha. Now, to get this angle, we have to do, well, what this says here. So if it's in quadrant 2, we are taking 180 degrees minus, well, the given angle here. So theta is the given angle. So this may be like, I don't know, like 120, for example. So to find this reference angle, alpha, you must take 180 minus the 120, and that would give us 60 degrees would be the reference angle. And as you probably already read, the reference angle is formed between the given angle and the closest x-axis. So whether it being negative x-axis or positive x-axis, it's always formed with the x-axis. Is that clear? This concept right here is also important because we're going to use it quite a bit the next 3 units. So you might hear me say reference angle quite a bit, and you need to understand what I'm saying. All right, this page is also important. This tells you actually how to calculate the reference angle. And if you have a picture, it kind of makes sense. So the first one, quadrant 1, the given angle, theta, and the reference angle, alpha, they're the same. There's no math needed to calculate this angle. But for in quadrant 2, that formula is alpha is equal to 180 degrees, which is a half a rotation, minus the given angle theta. So that kind of makes sense, I hope. Everyone doing good so far? If we're in quadrant 3, the reference angle alpha, formed by negative x-axis and the terminal ray, is calculated by taking the given angle, which is starting here, going all the way around, and we are then subtracting out a half a rotation. So it's going to be the given minus 180 degrees. And that leaves us with alpha. I think it makes sense. Seeing is believing, right? And then lastly, if we're in quadrant number 4, to get the reference angle alpha, you are going to take 360 degrees, so take a full rotation, and we're then going to subtract out theta, which is the given angle. So again, 360 minus the given leaves us with just this piece here, which is the reference angle. And by the way, reference angles are always positive values. So you can't have a, well, I guess you could have a negative reference angle. No, you can't. If you have a reference angle, alpha should be positive. Now the given angle, theta, can be negative. But the reference angle, the angle formed with the terminal ray and the x-axis, that's a positive value. All right, we good on this slide then? Okay. All right, let's do number 1 together. So number 1, is that kind of fuzzy for you guys? Okay, it's fuzzy on my side. That's 230 degrees. That's 230 degrees. Number 2 is 160 degrees. Number 3, that's 330 degrees. And then number 4, that's negative 310 degrees. Okay. Well, don't you have just perfect vision? I'm jealous. Okay, number 1. To get the reference angle, alpha, what is our equation we have to create, or our expression we have to write? Go ahead and type it in chat. So theta minus 180, that sounds right. Theta minus 180. Yep, so the given angle is 230 degrees. We subtract out the 180, and that leaves us with this angle right here. Actually, I'm pointing and you guys can't see my pointer. So the angle formed between the terminal ray and this x-axis right here. And what is that angle? 50? I think 50 sounds right. Okay, everyone, quickly do numbers 2, 3, and 4. I'll give you all I think a minute and a half. Minute and a half sounds pretty good. Minute and a half. Minute and a half. Four is kind of weird. So for number 4, look at it and think about what makes sense. How would you find that reference angle? What makes sense? If it's, all right, time's up. If it's in quad, what does that mean? If it's in quad, then the reference angle is equal to theta, right? Quad. What is quad? Oh, quadrant 1? Oh, okay. Yeah, I misread that. Quad short for quadrant. That makes sense. I'm so slow this morning. If it's in quadrant 1, then the reference angle is equal to theta. You are correct unless the given angle is a negative degree. Then it's a little different, right? Because, so let's wait till we get to number 4. I'll just talk about it right now. So if you chose this is in quadrant 1 course, but if you chose, so theta is negative 310 degrees. So if you said your reference angle is negative 310 degrees, my question is, does this angle right here look like it's, well, 1, I said alpha has to be positive. And 2, does that angle look like it's greater than or less than 310 degrees? Well, the answer is no. So this angle here, which is alpha, your reference angle, should not be the same thing as theta, even though it's in quadrant 1. And it's because your theta is negative 310. Keep that in mind. Anyway, number 2, what is the answer? What is the answer to number 2? Go ahead and write in chat. We got some 20s. Looks like 20s. 20 sounds, I think, good. 20, yep. And that equation, that formula is 180 minus 160. Number 3, what is the answer? 30. I think 30 probably sounds good. Yep, 30 is correct. All right. Volunteer want to go on mic and try to explain of how you found the reference angle. I know words can be hard sometimes, but someone said sure. Julia, go for it. It's okay if you're wrong. I'm wrong every day about something. I make it a point to be wrong about something.
Testing, can everyone hear me?
Yes.
Okay, so we see that the terminal ray is in quadrant 1, and so I decided to follow the formula for quadrant 1, so I said that alpha equals 180 degrees minus negative 310 degrees, and we know that a minus and a minus gives us a plus sign, and that in the end gives us 490. That could be wrong, but that's how I did it.
It's a good guess. It's a good guess. I could see why you probably did it that way. So here's a question to you. Visually, this angle, this is also called, is this an obtuse or an acute angle? Anybody know? It is an acute angle, yeah. So this acute angle, does this look like it's even close to 410 or whatever you said? Yeah, it doesn't. So the picture doesn't quite fit the story. So in that case, I would probably retry it. Anybody else want to give it a go? Emily wants to go. All right, Emily, go for it.
Okay, so what it is it's about the coterminal angles. So basically what we need to do is find an angle that's equal to 3/10 that is above 0. So for that, all you would do would be to combine 360 and negative 310 to get positive 50, which would be the answer.
Ooh, oh boy, that was a good answer. You know what? And that wasn't the answer I was expecting. Bravo. I like that. That is actually excellent. I need to write that down. So if I teach this again next year, I gotta say that because that's good. So yeah, that is, yeah. So coterminal, to make it positive, we could just add 360, making us have visually the same angle, a coterminal angle, but now it's positive. And this way it fits all of our formulas. I think that's excellent. That's an excellent way to do this. So yes, so in that case, it would be 50. Yeah. Did anybody else do it that way? You know, I'm a teacher that I hate giving extra credit. I really do. I'm against it personally. But if I was somebody who actually gave extra credit, Emily, I would give you extra credit points for that one. Yeah, you know, so far every term, at least one person has taught me something or surprised me. And I like when that happens. Okay. Antonia, we'll take 5 points from you and give it to her. Nice guy. Nice guy. Yeah. So I actually like Emily's way better than doing it than what I did it. I just did 360 minus 310. I just treated it as, I guess, a positive value. So visually, I approach it from a visual standpoint, not from the formula. So looking at this, since we're going this way, 310 degrees, a full rotation would be negative 360 degrees. So I would take basically negative 310 and then subtract negative 360, and then I would get my 50. And that's what I did. But Emily's way is better. Makes more sense. No matter how you approach it, you should get 50. That's what's important. All right, everyone try this one. And I even gave you a picture. Actually, I gave you a picture of the other ones too. So, yep. So this one, negative 7 pi over 6 is this angle here. Emily's way of doing the coterminal to make it a positive terminal ray would work beautifully in this case. So you might want to approach it that way. Oh, by the way, those formulas of like subtracting 360 or the 180s, you can use radians by replacing 360 with 2 pi and 180 with pi. But everyone should know that because 180 degrees is pi and 360 degrees is 2 pi. But if you like converting radians into degrees, working with that, and then converting it back at the end, knock yourself out. I'll give you 30 seconds to finish this problem. That's funny. All right. Do we have an answer? Go ahead and write in chat if you have an answer. Yep. Emily and Caitlin, that's actually the same answer. I prefer Caitlin's form of it better. It's the same thing, though. So we got some pi's over 6's. Pi over 6. Pi over 6. You wrote what the calculator said. Yeah, so like the fx will write like 1 over 6 and then pi at the very end. Just stick that pi in the numerator because that's what it is. It's 1 over 6 times pi, which is pi over 6. So I think it is pi over 6. All right, to do the coterminal, let's do that. I'm going to call it the Emily method. To do the coterminal, we're going to take that negative 7 pi over 6. Where's my pen at? We're going to take that negative. Wait, what's the number again? I already forgot. Negative 7 pi over 6. And then we were going to add 2 pi, right? And just off to the side real quick, 2 pi, we have to make it have the same denominator. This is, nobody should be doing this by hand. You should just type this in. But to make this have the same denominator, you're going to multiply top and bottom by 6. And then that gives us 12 pi over 6. So remember, in order to add or subtract fractions, they have to have the same denominator. And 12 pi over 6 is still 2 pi. So I'm just adding a full rotation to make it positive. So negative 7 plus 12 is positive 6. Right. No. Right? Someone, what's negative 7 plus 12? Before I hurt myself. It's 5. Five pi over 6. Okay, there we go. So that means that this angle from here to here is 5 pi over 6. I told you guys, I have a hard time dealing with negative. Adding, subtracting negative numbers is like my weakest math. Go figure. So that means that's 5 pi over 6. So by using the formula that's given many slides ago, we do what minus what? What are we doing? What minus what? Theta is pi. Well, no, theta. Well, theta is 5 pi over 6. That's the given angle that we recalculated by making it positive. That's the coterminal angle. So we are going to do what? Emily is correct. It is pi minus 5 pi over 6. So because this is the angle alpha right here. This is alpha. That's a terrible alpha symbol, but it kind of looks like one. So we have to do 180 degrees minus the theta, and 180 is pi. So I would do pi minus 5 pi over 6. And to make that have the same denominator, I multiply top and bottom by 6. And 6 minus 5 is 1 pi. So that's why the answer is pi over 6. And that's if you approach it using the coterminal way, which I actually kind of like. You can also convert it to degrees. If you like looking at degrees better than radians, most people do. I know I do. You can do it that way too. And just convert it back to radians when you're done. But this is how I did it. I just did 7 pi over 6 minus pi. So visually, that's what made sense to me when I first looked at it. So I looked at it as 7 pi over 6 going this way, right? Negative. And then I just subtracted out the degrees of quadrant 3 and quadrant 4, which is pi. So visually, that made sense to me. This is 7 pi over 6 in the negative direction minus 180 degrees, or pi, and that's how I got positive pi over 6. So I necessarily don't follow those formulas. I draw a picture, I look at it, and I ask myself what makes sense here to get me that angle, and then I do that. So if you like the formulas, use them. If you like drawing a picture and looking at it and what makes sense mathematically, visually, do it that way. It doesn't matter. You should get the same answer. All right, reference angle. How much time we got here? All right, we have 20 minutes. Everyone quickly do 6 through 9. I'm going to give you all, I think, I'll say 2 minutes. I want to quickly get through this because we actually have another concept we have to cover in the next 20 minutes, and I want to get through. That's, I think, is more important than this. Well, not more important, but just another concept. All right, 2 minutes. And again, if it helps drawing a little picture of a circle in the quadrants just so you can see what it looks like, do that. I think it's very helpful. Got another 20 seconds left. All right, volunteer to write the answer for number 6. Is that what number? Yeah, number 6. All right, Dianica, number 6. How about number 7? Katie, number 7. How about number 8? Hello? No volunteers? All right, I'll just sit here patiently. No, things went perfectly when you volunteered last. We learned something when you went last. That's the important piece. Yeah, I really don't care if you guys get these wrong when you guys volunteer, because it gets an opportunity to have a teaching moment and learn something so we don't make the same mistake again in the future. And honestly, if you make a mistake, people will forget by the next day. It really doesn't matter. But in that moment, you're probably dying inside, right? Well, you know what? No one else volunteered, so you can judge them right back. Don't forget that. All right, so Katie was talking about she had an explanation in chat. I'm doing this for the recording. Her explanation was she used the coterminal to make it a positive coterminal angle, and then which means that alpha is 85 degrees. 85 degrees is correct. Yep. So volunteer for number 8. Anybody get that one done yet? All right, Emily, what's the answer to number 8? Neuro hates your Wacom. Yes, it hates mine too. So I have a ViewSonic ViewBoard, 55-inch touchscreen. What I use, and I have a stylus, and I bought one this last week, and it does same results in Windows. And then I have a Mimio Dymo, I think, or Dino. I don't know. It's like a Wacom board. I think the same company actually, but it's an older model, and it also hates it in Neuro. But if you ever use Google Jamboard, which is also a web-based whiteboard, and for people I've done one-on-one sessions with, I use Jamboard because it actually works compared to Neuro, a lot better. But anyway, I had the same problem, and what fixed it was using a Mac. So right now I am using my Mac for this lesson because I don't have issues writing on my Wacom board or my touchscreen while using my Mac. Go figure. So it's not. I wouldn't say it's necessarily a Windows issue. It's an implementation issue by Neuro, because if Google did it and theirs works in Windows with my touchscreen and Wacom, Neuro should be able to do the same thing because they're both web-based whiteboards. Okay, end rant. Where's my glasses? You know, I had a sticky note I picked up, and I don't know. There it is. All right, I'm just seeing what the answer is. So number 7 looks right. Number 6. Number 6 is also 85 degrees. So yep, 6 and 7, 85 degrees for alpha. Number 8. Looks like we're getting to the final answer right now. Looks like it's 29 pi over 90. That is correct. Nice job. And then number 9 is pi over 18. That is also correct. Nice job. All right, let's go on. These were fun. Question?
Can you go back to the last slide so I could explain it really quick?
Sure.
Okay, so for number 8, I converted it into 122 and then I got 58. How do you convert it back to where you get pi?
So to go from radians to degrees, you multiply by 180 over pi. So to go back, you multiply by pi over 180. So in your notes somewhere, this is from, I don't know what day we had this, but I would have that maybe like boxed of the conversion going from to and from, I think is important to have written down. And then you would get the same answer. All right, we good. Okay, slide 12 of 20, and we have 10 minutes. I can do this. All right. So from previous pages ago, we already talked about this. Cosine is x over radius, sine is y over radius, tangent is y over x. This is important to know. And then there's the picture to represent that. So cosine, this makes sense because the cosine of this angle is opposite, which is, I'm sorry, that's sine. Sine is opposite, not cosine. Cosine is adjacent over hypotenuse. So cosine of angle, adjacent is x, hypotenuse is your 1. That's why it's radius. Sine, that's opposite, so there's your y value, divided by hypotenuse, which is your radius, which is 1. And then tangent is opposite over adjacent, so tangent is opposite, so y divided by x adjacent. Just a little recap of that. All right, so we want to find the given ratio. So we're not solving for theta, we're just setting it up. So one thing that we can do is, if it helps to like plot these points so you can see what quadrant they're in, it would be very, very, very helpful. But you really don't need to. So I'm gonna show you of why you necessarily don't need to plot these. All right, so x is -4, 1, 2, 3, 4, and then up 3, 1, 2, 3. All right, so there's that point. So that goes from here to here, right? So that means there's the angle, right? And then we just drop that down, and then there's your 90. So we have to create, remember, you have to create the alpha angle, the angle created between the terminal ray and the x-axis, whether it's positive or negative. And then for number 1 on this page, so this is -4 in the x direction, and then the y is +3. So create a picture, and then going from that previous page, those formulas, that cosine is, so the cosine of angle is equal to adjacent over hypotenuse, which happens to be the x value, right? Because cosine is x over radius. And if you look at it graphically, you can see that the adjacent side to that angle is -4, so they're both correct. So it's x over the radius. Now the problem is we don't know the radius. So maybe drawing a picture is a good thing in this case. So how do we find the hypotenuse side? So does a triangle have to be completely inside the circle? Yes. The problem is I have the circle drawn first, which you actually should draw the x and y coordinates, plot the points, draw your radius, and then do the circle so it lines up properly. Honestly, I didn't really have the time or more like the willpower to create proper circles for all of these. So I just have this generic one on the screen to draw on. Sorry. We solve using yeah, you can. Yeah, I guess you can. You can use I guess you can use no, you can't because we don't know the angle. No, you can't. Sorry. Yeah. How do I find the length of the hypotenuse? How do we find the Pythagorean theorem? Yeah, a squared plus b squared equals c squared. So to find that, we do the square root of 3 squared plus -4 squared. And that equals your side C, right? So what is the length of the hypotenuse? 5. Yep, that is a 5. And if you remember from geometry, that is a 3, 4, 5 triangle. So if that looks kind of familiar, because there was a special right triangle that fit this, it's a 3, 4, 5 triangle. You could have done it that way too. All right, so going back to the original problem, so cosine is the x value over your radius, and we now know the radius is 5. So cosine of theta is -4/5. Yep, not 45 degrees. All right, we good on the first one here? So kind of recap this problem. Remember, cosine is equal to your x value divided by the radius. The x value is -4 because that's given. And the radius we actually had to calculate by using the Pythagorean theorem. So let's look at number 2. And I totally forgot that I actually have all of these on individual pages. That was smart. Now this one, we don't have to draw a picture because based on those formulas, remember cosine is x over radius, sine is y over radius, tangent is y over x. So that means tangent of theta is equal to what over what? 13/4. Yep, 13/4. Y over x. Now let's draw a picture here. So this is in quadrant 1. So we'll say over 13 and then up 4. So we'll pretend that's right here, which is totally wrong. And then I draw a line through it, right? Yeah, we'll just pretend. And then that means that is your alpha angle. And then this would be creating your right triangle. And the x value is, what do we say x value was? 4. And then your y value is 13, right? So graphically, looking at your angle alpha, tangent of theta, or alpha, is opposite 13 over adjacent, which is 4. But in this case, creating the picture actually took way longer than needed when we could just actually, we know that tangent is y over x. Does that make sense? I know a lot of times my explanations are probably too long, and I think this is one of them. All right, I don't know if that was English you typed in chat, because I don't know what those words mean. Well, I'll just pretend I never saw it. All right, next one. So the sine of this is going to be, all right, what is that? What goes on top? We'll start there. What goes on top? Without drawing a picture, what goes on top? Yep, -4, which is the y value. Yep. So we put a -4 on top. Now, if you can think about how triangles are formed, coordinate-wise, you have an x direction and a y direction. So in the coordinate, you are never given the radius. So if we know we need the radius on bottom, we can just use the Pythagorean theorem without even drawing a picture. So a squared plus b squared equals c squared. So it's going to be square root of 3 squared plus -4 squared. So I'm kind of taking pictures of knowing how the triangles are created given coordinates, and having the x-axis being the angle that alpha is formed with. So 5. So what goes on bottom? 5 goes on bottom, yep. So there's your answer. Sine of theta is -4/5. And to draw a picture, so over 3 down 4. I'm just going to quickly do it. 1 over 3, 1, 2, 3, down 4, 1, 2, 3, 4. And then I just draw a line. So there's your angle. Remember, always with the x-axis. So to form the right angle here, there you go. So that's 1. Oops, I obviously, x is 3. Yep, I did that right. Over 3 and then down 4. That's a -4. And Pythagorean theorem, and that's how we got 5. So this is all making kind of good sense. All right, you're gonna, so if you're leaving early, really go back and watch the very end of this video, because we're kind of leading into the final piece that we have to learn, which is really important. So let's, I'll do this one as bell work tomorrow. How about that? So I'm gonna skip it. Cosine of theta, 7 comma radical 15. All right, let's go on. So this is recapping all that's fun stuff. All right, so the unit circle, by the way, this is available under course contents, under course materials. You can download this. I have this in PDF format and DOCX format. Download this, print a few copies of this. We're gonna need this unit circle for the next 3 units. And I can't put this on every single slide that we need it. So I have a copy printed up for myself so I can refer back to it when we do some examples. But for today and some other lessons, I'm going to try to fit it on the page, but you need to have this printed up and you need to understand this. to talk about this, now all of you should have seen this in geometry, right? Yeah, you can use this on the test. Yeah, when I taught this course in person, we learned, I taught them actually how to create this circle from a blank circle. And then for their exam, they were given a blank circle and they had to recreate this circle to use it on the test. But I'm not going to have you guys do that. We have far more important things to worry about than doing that. All right, so this has the degrees. So 0, 30, 45, 60, 90, all the way around to 360 degrees. This number is the radians. 0 radians, pi over 6, pi over 4, pi over 3, pi over 2, all the way to 2 pi. These values in the parentheses, these are the coordinates. Now, for the unit circle, the radius is always 1, which is a very good thing. The radius is always 1. So that's why we have, for this point here, this is 1 comma 0. This point is 0 comma 1. This point is negative 1 comma 0. This is 0, negative 1. And then we have coordinates of different degrees in between those. So that's the unit circle. So far, so good. All right, so again, sine is y over radius, cosine is x over radius, tangent is y over x. So this is no big surprise here. I think I have this on the next page. Let me double check. I do not. Okay. So to find the sine of 90 degrees, well, we could type it in, but the whole point of using the circle is to avoid typing this stuff in. All right, so the sine of 90. Now remember, sine is associate sine with y, cosine with x, tangent with y over x. That is super important to associate. And because the radius is 1, y over 1 is just y. So that's why sine is the y value, cosine is the x value, tangent is y over x. Hopefully that's very clear. All right, so the sine of 90. So we go to 90 degrees. Get my pointer out here. We go to 90, which is here, right? 90. And because it's sine, we want the y value. So the sine of 90 is equal to 1. So we write, well, that equals 1. And if you want to confirm, type in sine of 90, hit enter, you will get 1. Cosine of 90 degrees. So we go to 90 degrees, and then we want the x value. And the x value at 90 degrees is 0. So if you want to, go ahead and type in cosine of 90, hit enter, you will get 0. And then tangent. Tangent is y divided by x. So at 90 degrees, we take the y value, which is 1, and we take the x value, which is 0, and we get undefined. So remember, you cannot divide by 0. So if you type in tangent of 90 and hit enter, you will get an error. So I'm just going to write undefined here. Undefined. All this should be falling into place and making sense, because this is really important. This makes sense. Just remember, cosine is x, tangent is y over x. Remember that. All right, well, we good so far? All right, all right. And again, this page, we're going to be using this concept for the next 3 units. All right, so everyone, look, without typing it in your calculator, unless you want to verify your answer, you can. But the cosine of 120, using the unit circle, what does the cosine of 120 equal? Go ahead and type it in chat. Most of you are agreeing, -1/2. So let's see if that's right. So cosine of 120, so 120 degrees, that's right here, right? 120 degrees. And cosine is what variable again? What's the variable for cosine? X. Yeah, X. So we look at the coordinate. So that means the cosine of 120 is equal to -1/2. So that is the answer, -1/2. And to verify, you can always type in cosine of 120, hit enter. You will, in fact, get -1/2. Kind of neat. All right. What is the sine of 7 pi over 6? The answer is also -1/2. Yeah. So sine is the y value. Very good. And if we find 7 pi over 6, and then the y value, I'm using my pointer to point to that. So 7 pi over 6 is right here. Sine is the y value, so the y value in the coordinate is -1/2. So that is the answer. Is -1/2. And we can always type that in and hit enter. Make sure your calculator is in radian mode, because we are taking sine of a radian value, not a degree. So if your calculator is in degree mode, you type in 7 pi over 6, your answer, I don't even know what it would be. Yeah, it wouldn't work. It's something else. Do I have these on different pages? Oh, no, this is our last slide. All right. Tangents of 7 pi over 4. 7 pi over 4. So what? So let's go to 7 pi over 4. That's right there. So how do I calculate tangent? What do I do? Yeah, y over x. So a lot of you are already putting -1. And you can easily see that at 7 pi, y is negative radical 2 over 2, and x is radical 2 over 2. Well, y divided by x will give us -1, because we have negative, this number divided by positive of the same number will equal -1. So there's really no work for me to even show, because you can just look at it visually and totally see that you get -1. All right, and then lastly, cosine of 330 degrees. What is that one? What is that answer? A lot of square root 3 over 2. So, yep, radical 3 over 2. Yep. Well, is it positive or negative? I see there's people are disagreeing on it's positive or negative. Now, it is positive. Yeah, remember, because cosine is the x value. So we go to 330 degrees, which is right here. The x value is positive radical 3 over 2. We care about the x value for cosine. So radical 3 over 2. And that's it. So this concept we just went over, this is super important. I can't stress it enough. You need to understand cosine is x, sine is y, tangent is y over x. And we're going to be using this unit circle. So go to the course content under course materials, under resources, and you can download the PDF or the document of this and print it out. You need to use this. You need to understand how to use it. All right. I hope you learned something, guys, and I will see you, well, I'll see you tomorrow, but I'll just be in the room because we have that meeting or whatever. But our next class will be on Monday, but I will be sending out a recorded video of tomorrow's lesson. Unless, hold on, let me double check something before I stop this video. I'm going to see, maybe I can just push everything one day. Let me look. All right, today is February. Oh, by the way, tomorrow's my birthday, guys. Make sure you guys bake me a cake. Let's see. We have... So actually, I could push it... I could push everything one day. So that means just like last semester, we would do a lesson on Monday, which would be the last lesson on Monday. Then on Tuesday, we will actually have the review and the test, which is what we did last semester too. So do you all prefer that way, that I actually have a live class and that way you can all be here to ask questions? Okay, let's do that then. I'll just push the classes one day and then we'll have the review and the test in the same day, which is really not a big deal. All right, let's do that. All right, guys. Well, hope you learned something and see you next time.